Now, let's build on the little video clip you just watched, and let's do a couple more examples together. So, when I look at number 3 example, I'm going to let f of x be x squared. Its derivative is 2x. Its derivative is 2. Its derivative is 0. So there's my column of repeated derivatives until I dissolve to 0. I'm going to let g of x be cosine x. Its antiderivative is sine x, because remember, when I differentiate sine x, I get cosine x. Its antiderivative is negative cosine x. Because the derivative of cosine x equals negative sine, the derivative of negative cosine x equals positive sine. Now, the antiderivative of negative cosine x is negative sine x. Remember, the derivative of sine x is cosine x, so the derivative of negative sine x equals negative cosine x. Now what I'm going to do is draw my diagonal lines from top left leading down to bottom right, and then you stop. Okay? So at this point, I also need to remember there's a sign pattern that's important. So I always lead with addition, then go to subtraction, then go to addition, and I'll continue to alternate if I've got more and more entries in the two columns. So all I have to do at this point is say, okay, well, I can tell you what the answer is to my integral. I'm going to say it is x squared times sine x minus, because I've gone from plus to minus 2x times a negative cosine x, and then plus 2 times a negative sine x plus c. Now, most of us will do what I'm going to do in one step rather than writing it in 2 steps. That's fine. I'm just writing it in 2 steps this first time around. So I'm going to clean up my answer to x squared sine x plus 2x cosine x minus 2 sine x plus c. Now, it says at the bottom of the slide here that if you differentiate what you've gotten, will you get back to the original integrand? Well, I mean, let's check. Let's just see. And we won't do this on every one, but let's check on at least one. So I'm going to have to use product rule quite a bit. So to differentiate first term, x squared sine x, remember, very droopy underpants. V du plus u dv plus, I got to do it all over again, v du plus u, I'm going to drop down to this next row to make a little bit more room. So plus u dv. And then I have to do my derivative of my third term, fortunately, which is just negative 2 cosine x. And of course, the derivative of any constant term is just 0. Now, does that clean up? Well, notice here I've got positive 2x sine x. Here I've got negative 2x sine x. So those cancel. Here I've got positive 2 cosine x. Here I've got negative 2 cosine x. So those cancel. So notice what I'm left with is x squared cosine x, which was the original integrand. So yes, I know now that I have done integration correctly. Let's do one more. I'm going to skip 4, and I'm going to go to 5. So if I said, well, please solve this differential equation. Your first step is easy. Uh-oh. I just realized the original problem was written wrong to begin with. I shouldn't have had 2dx's in the problem. So we'll just pretend like that wasn't there. Sorry about that. Now, I know that to solve for y, and I am looking for y, I simply integrate both sides. So I'm going to say y equals, and now of course I've got to actually do the antiderivative of x squared minus, or x cubed minus x squared. Let me call the x cubed minus x squared f of x, and let me go through the derivatives here. So I've got 3x squared minus 2x. Then I've got 6x minus 2. Then I've got 6. Then I've got 0. Do you see I'm just doing repeated derivatives until I dissolve to 0? That means 2 to the x has to be the one that I find repeated antiderivatives for, or I repeatedly integrate. So I know the antiderivative is 2 to the x over ln 2. So the antiderivative of that is, again, 2 to the x over ln 2 over ln 2. Okay, I don't like the way that's written, so let me write it this way. Plus, I'm trying to make room on my table here. That would be the same thing as saying times 1 over ln 2. Or I could say 2 to the x over ln of 2 squared. Well, do you see that the pattern's going to be that now I'm going to have 2 to the x over ln of 2 squared over a new ln 2? So is it all right with you if I say I'm going to get 2 to the x over ln of 2 cubed? And then my last one would be 2 to the x over ln of 2 to the fourth. Do you see how I've gotten that? So let me make sure and connect correctly here. So I'm going to say 1, 2, 3, and then 4. And let me go ahead and remind you that we start with addition, go to subtraction, back to addition, back to subtraction. So now I'm going to fill in what I know about my answer. So I'm going to say the first term is 2 to the x over ln 2 times x cubed minus x squared. So I've got this one done. Now the next one I've got to say minus 2 to the x over ln of 2 squared times 3x squared minus 2x. So now I've gotten the second one done. The third one, I'm going to say back to plus, and I'm going to drop down here. 2 to the x over ln of 2 cubed times 6x minus 2. So last but not least, I need to subtract 2 to the x over ln of 4, no, I'm sorry, ln of 2, my bad, to the fourth times 6. And then I'm going to say plus c. So there's my general solution for the differential equation.